A very good morning. So yesterday's questions winners are displayed. The first answer was done by Preeti S. So congratulations, Preeti. Second, it was by Kirtana Cecilia. So congratulations, Kirtana. And the third answer was given by Dhanalakshmi. So congrats, Dhanalakshmi. The first three students who gave the answers correctly yesterday are these three. So congratulations to Preeti, Kirtana, and Dhanalakshmi. So yesterday we were seeing about your 1 mark and 2 mark questions. Today I told you we will be seeing the question paper questions which have arrived from this chapter. Before looking into that, 2 questions were left out. We will just complete that up. The last we stopped with was yesterday. You had to do the limitations of Ohm's law. See, there were 4 points given. They are not used in semiconductors. When temperature does not remain constant, they are not useful. They are not useful if all physical conditions remain constant. So the same thing, the variation between current and potential difference is not linear, meaning it is not along a straight line. This also can be written. In case you forget those points, you can add up these points. Second point is relation between current and potential difference is not unique. That means it is not separate. And Ohm's law is not applicable for semiconductors. So this is continuation of yesterday's point. Semiconductors, you can write when temperature does not remain constant and when all physical conditions are the same. This question I just want you to see. Derive the vector form of Ohm's law. See, in Ohm's law, the general formula is V equals I into R. If we have to derive it in vector form in terms of J, this is called as sigma, and capital E, then we have to do the small derivation. So they ask you for 3 marks here. So you can just have a note on this derivation here. We have a conductor, and across your conductor, we have a cell of potential V connected. That's your diagram. So one conductor or a wire, and V should be connected across it.
Okay.
The next thing is the derivation when you are doing. Let I be the current in the conductor. If I is the current, your potential difference will be V. Then according to Ohm's law, V should be equal to I into R. I'm repeating it. We are deriving the vector form for Ohm's law in terms of J and capital E. We are considering I to be the current in the conductor. The potential difference will be V. Then according to Ohm's law, V should be equal to I into R. Call that as equation 1. Now we have a term here called E. That is nothing but electric field. What is electric field? If you have a charge, surrounding that charge for a certain region, electric charge force can be experienced, or the force due to that electric charge will be produced. That is called as electric field. It is the region around a charge. You take a magnet. If you have a magnet on a piece of paper and you put iron pieces to attract it, if you put iron pieces closer to the magnet, it will attract faster. As you take the iron pieces farther and farther, you take it a little far and go, the force of attraction will become lesser. You increase the distance more, it will not attract. So that iron has got that attraction capacity only to a certain distance. That distance we call it as magnetic field, since it's a magnet. Remove the magnet and keep a charge. That electric charge also will experience force in a surrounding region. That region is called as electric field. So the formula for that electric field is E equals V divided by L. L will be the length of the conductor and V will be the potential. So what is electric field? I think you understood. Region around a charge which experiences electric force. So formula for that is E equals V by L. Just cross multiply. We will get V equals E into L. Call that as equation 2. Now compare equation 1 and 2. Left hand side, you have V on both the sides. So we can equate our right hand side. So I will write EL is equal to I into R. So here what we will do is keep EL as it is. Keep I as it is. Resistance, previous classes we have seen this formula. R equals rho into capital L divided by capital A. Rho is resistivity, L is the length of the conductor, and A is the area of cross section. Brackets, I've given you the formula. So we are substituting the formula for R. After you substitute the formula for R, what will happen to the equation is EL will remain as it is. I is here. In your denominator, you have A. This I by A is nothing but J. J is called as a term current density. Current density is current divided by your area of cross section. That is called as the current density. So observe this carefully. I divided by A will become J. Rho as it is, you will write. What is left out is L. So two substitutions we have done. In place of R, I'm writing it as rho L by A. I by A is written as J. So this formula will become rho L multiplied by J. We have one more substitution. 1 divided by rho will be equal to this formula sigma. So what we will write here is the L here and L here will get cancelled. So this L and L will get cancelled. We will get E is equal to rho into J. Now I want to remove this rho and introduce a term which is called as sigma. So what is that relation is? 1 by rho will be equal to sigma. So instead of rho, you can write 1 by sigma into J. So 1 by rho will be replaced here. E equals 1 divided by sigma into J is your formula. Then if you cross multiply, you will get J is equal to sigma into E. I'm telling you this point again. Here we are substituted for R. Then I by A is J, current density. Cancel L on both the sides. You will get E is equal to rho into J. One more substitution is rho is 1 by sigma. So what I will get is E equals 1 divided by sigma into J. If you can cross multiply, J will remain as it is. E into sigma will come towards the other side. So this is the vector form of Ohm's law. So going to our next question. Now we told you yesterday, resistance in terms of conductors, it is directly proportional. And in terms of semiconductors, it is inversely proportional. That is what we are writing the symbol here. If they ask you to plot a graph, what you should do is temperature will be plotted along your x-axis. Resistivity, denoted by the symbol rho, will be plotted along your y-axis. So they will ask you to draw a graph for temperature dependence of resistivity in case of metals and in case of semiconductors. See, this metals term can also be replaced as conductors, okay, because conductor and metals allow current to pass through them. Semiconductors have the properties of both metals and non-metals. So your question, if it is metals or if it is conductors, will be the same answer. So to draw a graph, x-axis will be temperature, y-axis will be your resistivity. Keep in mind, in metals, resistivity is directly proportional to temperature, meaning resistivity increases, temperature will also increase. Vice versa, resistivity decreases, temperature will also decrease. So rho is proportional to T in case of metals. Look at your graph, you can see it is linearly increasing. So from a point it is going up. This should be your graph in case of metals. See, in semiconductors, resistivity is inversely proportional. What is the meaning? I increase my resistivity, the temperature has to come down. Or if resistivity is becoming less, temperature will increase. That's why we wrote it is inversely proportional. Rho is inversely proportional to 1 divided by T. In metals, it has to go up. See, in non-metals, it has to come down. What is this line if you're confusing? This is at rho naught and T. 2 points at initial temperature, that is at the point 0. So in metals, curve should go up. In semiconductors, the curve should come down. In metals, it is directly proportional. In semiconductors, resistivity and temperature are inversely proportional. So these were the few short questions which were left out for you apart from the question papers. Now what we will do is, see, question papers, why we revise in every chapter, I told you earlier, this chapter has a weightage of 13 marks. So for 13 marks, what type of questions will appear in the question paper? Should we concentrate on 1-mark questions, or should we concentrate on 5-mark question? How many times the same question is repeated? If you can get an idea on that, keeping that, we can prepare. So this chapter, 5-mark questions is important, problems is important, and 2-mark questions are important. Color coding, they will ask you for 1 mark. And all 2-mark questions are definitions, say like Ohm's law, or they can ask you the definition for resistance, resistivity, conductance, drift velocity, mobility, so all those questions. What we will do now is, I will display the questions. You can just mark it in your text notes, or I will share the slide with you. You can mark. You don't get any questions, I will let you know. Okay. So the next question is, from the chapter of current electricity, which year, how many questions have appeared, and I have put them into subdivisions like the topic. See, your first question is, what is drift velocity, and how many times it has appeared is once in July 2014 and second time in March 2018. So I think you know the answer for drift velocity. The velocity of an electron drifted towards the positive of the potential against the electric field, we call it as drift velocity. So you can mark that as important. Second question, derive expression for drift velocity in terms of relaxation time. So this is asked in March 2016 and July 2016. So here, these questions are from question papers of 2014 to 2019 June. This year's questions I have not added up. We do that question paper a little later. So drift velocity derivation you have, Vd is equal to I divided by Na into E. That derivation should be answered here. Third question, write expression for drift velocity in terms of current and explain the terms. So if you are explaining the terms, what is I, what is N, E, A, those terms should be explained. So under the topic drift velocity, you have to learn what is drift velocity. You have to write the expression for drift velocity in terms of current, question 1, in terms of relaxation time, question 2. Relaxation time, yesterday we saw the time between any two successive collisions between the electrons, we call it as relaxation time. So our next topic, what is mobility and what is relaxation time? These are for 2-mark questions. Check this question, define mobility. So define mobility, how many years it's repeated, you just check. March 2014, 2017, June 2017, again March 2018. You know what is mobility, definition for mobility, and SI unit, yesterday we saw. So what is SI unit for mobility? Same way, you should also define what is relaxation time. All these are there in your notes, so just make a note. Next question, what was asked in March 2017 is, name the SI unit for current density. So this again is a 1-mark question. All your SI units will be asked in 1-mark question. Our next topic to cover is Ohm's law. Very important question. You can see how many years it is repeated. One way or the other, they will ask it. First part, how they ask is, state and explain Ohm's law. Or they can ask you, what are the limitations of Ohm's law? Or what is ohmic device? Give an example. Yesterday we saw ohmic devices obey Ohm's law. Non-ohmic devices do not obey Ohm's law. Now give an example for ohmic device, means any conductor you can tell. Steffi, Margaret, you have a question? Yes, Steffi? You can unmute and ask. You have any doubts, Steffi?
Yes, ma'am. Your voice was not audible, so.
Now?
Can you repeat that last question, ma'am?
Fine, I'll do it. The last question is, what is the SI unit for mobility? After that, you have defined relaxation time. So relaxation time is the time between any two successive collision between the electrons. The next question is, name the SI unit for current density. That was asked in March 2017. Then we have this Ohm's law. State and explain Ohm's law. Mention the limitations of Ohm's law. What is ohmic device? Give an example. Ohmic device is a device which obeys Ohm's law. Example, conductors. If they ask you what are non-ohmic devices, then you can tell they do not obey Ohm's law. Example for non-ohmic devices are semiconductors. I think I'm clear. Ohmic device, example, conductors. Non-ohmic device, example are semiconductors. These are all your 1 mark and 2 mark questions, majority of them. We'll go to the next topic. How does the resistance vary with dimension? First question on this is, on what factors that resistance of a conductor depend? So there are factors like 4. Length of the conductor, area of cross section, material of the conductor, and the temperature. The 4 factors: length, area, material of the conductor, and temperature. These are the 4 terms which they depend. Next question is, how does resistance vary with length? So R and length are directly proportional. So if resistance is increasing, the length will decrease. I'm sorry, they are inversely proportional. Resistance of a conductor varies with length as inversely proportional. Next question, define electrical resistivity. Resistance per unit length, that is called as your resistivity. That was asked in the year March 2019. Derive expression for electrical conductivity of a material in terms of relaxation time. So this is sigma is equal to E divided by rho. That derivation just now what we saw, that can be written for this term. Mathematical forms of Ohm's law, vector form. Today I showed you J is equal to sigma into capital E. There you can just rearrange the terms and write sigma is equal to J divided by capital E. This relation is asked, equivalent forms of Ohm's law. Today what we did, that is this question. Now when you take a carbon resistor, this color coding, they will ask you questions like this. Like letters will be given, red, red, orange and gold. Write the value of the resistance. That answer you can write it in numbers if the colors are given, or they will ask you to write the color code for a resistance of 45 ohms. When you take 45, B Roy, B stands for brown, black, red, orange. So 4 means it is orange, 5 means it is yellow, and there's no number after this. That means we have to take it as 0 into 10 to the power of 0. So this will be yellow, I'm sorry, orange, yellow, brown, 10% will be for gold. So that is how you have to write what is the value for your resistance in terms of the color coding. Then variation of resistance with temperature. Now here represent graphically the resistivity of copper and nichrome with absolute temperature. I showed you a graph here. Nichrome and thing are metals. So which is a semiconductor, you will draw a graph like this. If it is a conductor, you will draw a graph. It has to move on the upper side. So here for copper, it is a metal. That will be the first thing. And nichrome is a semiconductor. So you can draw the second diagram for a semiconductor. X-axis should be temperature. Y-axis should be resistivity. If it is metal, curve should go up. If it is a non-metal, the curve should come down. The next question for you is, these are your 5-mark questions, what I told you. So very easily you can remember. See, these, what is an equivalent resistance? If they ask only that, it will be a 1-mark question. If they ask you together with this, it will be a 5-mark question. Equivalent resistance, a single resistance which produces the same effect as a combination of resistances is called as your equivalent resistance. Obtain expression for equivalent resistance when two resistors are connected in parallel. That's what I told you when we were deriving. Majority they will ask questions for parallel. Very rarely they ask in series, but it's not a problem to learn that also and keep. And you can see it's repeated for more than 3 years. So in a span of 4 years, this question is repeated. Two resistors connected in parallel. It is not compulsory they should ask only parallel, series or parallel. Anything can be asked. So they repeat this parallel combination many times. And you should never get confused. Read the question twice. If it is resistors, you should derive it for resistors. If it is cells, you should derive it for cells. The next question is derive expression for equivalent EMF and internal resistance when two cells are connected in series. That was asked in 2017. The same question when two cells are connected in parallel, that is in March 2018 and March 2019. So we have 4 questions here: series combination of resistances, parallel combination of resistances. 2 questions: series connection of cells, parallel combination of cells. So these are the 4 5-mark questions what you can expect. And one more 5-mark question is this: state Kirchhoff's junction rule. Junction rule is the Kirchhoff's first law. So just for you to get confused, instead of asking state Kirchhoff's first law, they will ask you to state Kirchhoff's junction rule. So the algebraic sum of the current at any node is 0. You have to write that out. Your second question is state Kirchhoff's second law, or we can call it as voltage law, or you can call it as the loop rule. The algebraic sum of the EMF is equal to the algebraic sum of the product of current and resistance. That is the second law. So first law and second law. Check the next question for 5 mark. Obtain expression for balancing condition of Wheatstone's network. We did this one full class, we took only to do this because you see the number of years it's repeated. July 2014, March 2016, July 2016, March 2017, March 2018, and again in June 2019. So what is that balancing condition is? P by Q equals R by S, that derivation. That's one 5-mark question. So this chapter, you have to be thorough with only 5 questions for 5 mark. I'm repeatedly telling it. Cells in series, cells in parallel. Resistors in series, resistors in parallel. And balancing condition for Wheatstone's bridge. What is the condition of balanced state of Wheatstone's network? 1 mark question. You have to only write Ig is equal to 0. That is, current through the galvanometer will be equal to 0. Or if they ask you in terms of resistance, P by Q is equal to R by S. Other way of asking question here is they can ask you to draw the Wheatstone's bridge and write the condition for its balance. So only the diagram can be asked for 2 marks. When we take Kirchhoff's law, statement of Kirchhoff's first law, second law is important. Wheatstone's bridge, if you take, diagram of Wheatstone's bridge is important. What is the balancing condition for Wheatstone's bridge is important. Then you will write the derivation of Wheatstone's bridge. That is also your important questions what you can learn from here. So this is what are the questions which were asked from April 2014 to June 2019 in this chapter. So having seen this, you will get an idea of what to prepare. It doesn't mean you have to learn only these questions. Concentrate more on these questions. Other questions which are there, you can go through your textbook, because next year they may change questions also. But these questions are like a template. If you're picking up easy questions, all your questions will be from this. So make clear only 5 long answers. The remaining are all 1, 2, and 3 mark questions. If you have any doubt, somebody is